Hello, can you hear me?
Yes, Prof.
Okay. Okay. Only 4 students, huh? Hello?
Yes.
Okay. Can you introduce yourself? On the camera first. I just want to know. You give me your name. Give me your name, origin. Okay. Origin, and then what semester you are. Okay.
Okay. I'll start first. My name is Hong, and I'm from I'm Malaysian from Malacca, and then I'm in the last sem 3.
Okay. Next. Next.
Good morning, Prof.
Yeah.
Yeah, my name is Li Xun. I'm from China, and this is my 3rd semester. And this semester I just start my project 1, so I think I have 1 semester left.
All right. Thank you.
Good.
Next.
Hello, Prof.
Yeah.
My name is Naveen, and I'm from GB, from Malaysia. And this is currently my last semester, my 3rd semester. And currently doing a master's project too.
Thank you. Next, last one.
My name is Jun Ye, and I'm from Prerequisites, Japan. This is also my 3rd semester, and it's my last semester.
Uni from Malaysia.
Yeah, Seremban.
Okay, so only one international lah. Li Jin, from China. Li Jin, you are in Malaysia or in China?
Prof, I'm still in China. You know,
Right.
the COVID, I can't leave my city. My city is locked down.
Okay, all right. Okay, where about China?
Northern China, Shandong province.
Shandong province. Okay, thank you very much. Can off your camera. Okay, so can you see my slide? Can you see my slide?
Yes, yes.
Okay, so I already shared with you. Okay, so good morning everyone. So this is MKEM1763 System ID and Estimations, or some people call it as data-driven modeling. Okay, so in this introduction talk, I will talk about some introduction, objective and synopsis, the outcomes, the syllabus, lecture planning, assessment, timetable, and references. So this is the last offer of MKEM 1763, and next semester will be MEEM, no K, MEEM, new code 1763, System ID and Adaptive Control. So 2 subjects will be consolidated under 1 subject. So I hope everybody can pass this subject, okay? B- and above, okay? So that there is no repeat lah again on next semester. So this is myself as the lecturer, last minute call last week. So I'm sorry, last week we cannot have the class because I'm waiting for the timetable and arrangement. And this is the Thursday, so I took this opportunity to have a class at 11 a.m. Okay, my name is Muhammad FUA'AD, graduated from UTM 1989. Masters in Control System from University of Sheffield 1993. PhD in Instrumentation Control in 1996. I have 32 years experience as academicians. Before this, I hold several admin posts as the head of department, off-campus program, control instrumentation engineering department for 2 years, postgraduate manager 2012-2014, and dean of UTM space 2015 and 18. Then now I am the head of Proton Eye Research Group, okay, 2019 until 2025, okay, has been renewed until 25. So I also engage in the professional body, okay, senior member IEEE under Control System Society Malaysian chapter and member of IET. So how to contact me? Via email, or now is via WhatsApp, okay, the faster one. So I will try to help and entertain, okay, on the subject understanding matter. Okay, so you can go to my URL for details at the MKEM1763, where I park all my lecture materials beside e-learning. So I still didn't load anything at e-learning. I will do it later, okay, by this weekend. So as academicians, we always refer as the Google Scholar and Scopus H-index, okay. So my H-index and the Scopus is 21 and Google Scholar is 27. So for this subject, it's an elective subject. So I believe you already took these 4 subjects compulsory in order to graduate of masters, which is advanced instrumentation and measurement, linear system theory, discrete time system, design of microprocessor-based mechatronic system. Okay. So for elective subject, we have many varieties: artificial intelligence, advanced process control, adaptive and self-tuning, modeling and simulation, system ID and estimation, multivariables, nonlinear robust control, and advanced robotic. So you are taking the yellow one, okay, 1763. And then next semester, this will be combined with adaptive and self-tuning control with system ID under one subject, MEEM. Okay. So, and then you have the master's project and then other university subject taken for the program structure. So what is the objective of this subject? System ID is to expose students regarding the theory of system ID and estimations, and to introduce the basic concept of the reverse modeling, okay, including experimental protocol, test signal, model structure, parameter estimation, and model validations. So usually, sorry. Usually, okay, we have 2 types of modeling. Okay, can you see my iPad? Can you see my iPad?
Yes, bro.
Yes, Prof.
Is the first principle. Then so first principle, usually we use the law, okay. For example, Kirchhoff current law, Kirchhoff voltage law, and then thermodynamics. During our undergraduate study, okay. So this one mean derivation, okay. Derivations using a formula to get the model, okay. And the other one is we don't use any first principle law. We just have a data, input and output. Okay, so from input and output, then we can construct the model. So this is the unknown model. Okay, so we will input, and then we capture the data. Okay, and we get the using a SystemId technique, then we get the model. Okay, so the model can be in transfer function, usually transfer function, or state space representations, or differential equation. Okay, so usually transfer function lah is the best that represent the estimate model for the unknown model. Okay, so we have a real measurement, then we have the estimated. Okay, estimated model. So this real and estimate will be compared together, okay, to see whether it fits in a good shape and good presentation, best fit. So this is the way I conduct my lecture. I switch between my laptop in Zoom and then go to the iPad for the whiteboard. Okay, then I will share some MATLAB programming. Okay, so I hope you install MATLAB programming, MATLAB software in your laptop. So the synopsis consists of technique of SystemId, technique of parameter estimation, acquiring data, okay, and then pre-processing data. Then we have a non-parametric model technique, then parametric model technique, and then analyze, validate the model, and then convert to the system model, and then we have a case study. Okay, because SystemId must have a case study. Okay, so I will discuss some case study in the class. So just 4 of us. Okay, so should be no problem. So in order to do this subject, you need some requires of a deep understanding of control system, which is the modeling and analysis, and then control system design and the modern control theory for the state space representations. Okay, based on the theoretical base and practical implementations. Okay, so the key components: time frequency analysis, time and frequency response analysis, correlations, power spectrum, model structure, parametric model, non-parametric model, estimations of the parameter or coefficient values, test signals, and some model validation methods to verify the model whether it is acceptable or not acceptable. So for MKEM, we have a PEO, Program Educational Objective. This one is not included in the final exam, just to inform you what is the target after you graduate your master's, okay, to produce a postgraduate with multidisciplinary knowledge, okay, in designing, integrating, optimizing, okay, to the modern control and mechatronics system. And then to produce a postgraduate which able to generate new knowledge, idea and technique in control and mechatronics, and to produce a postgraduate that is prepared for R&D, research development, okay, and innovative industrial ventures. And then to produce postgraduate who are able to consistently perform their responsibility ethically and professionally. This number 4 is a very tough one lah. Okay, it's about ethics, attitude. Okay. So for the PLO, we have a 4 PLO. Okay, so basically our subjects is have a PLO 1. Okay, PLO2, and then design PLO3. Okay, and usually the 4 and 6 is the soft skills. Okay, 1 to 3 is the technical skills, and 4 to 6 is the soft skills. So for the subjects, we have able to explain CLO1, able to explain the fundamental basis of SystemId, which is usually correspond to number 1. Okay, CLO2, able to comprehend the fundamental basis of parameter estimations, usually is on the number PLO2. Okay, and then CLO3 is able to apply both fundamental above in the real case study, which is usually on the PLO3. Okay, then we have the assignments, okay, for these particular subjects, okay, but not included in the course learning outcome because it has been blended inside the CLO3, okay, in the real case study. So last week I received this letter appointment for the subject MKEM1763 for 4 students, and the timetable is shown here. Correct? Same like yours. So we have a class on a Tuesday at 2 p.m. and then Thursday on the 11 p.m. So for the assessment, I make it as simple as possible. We have 2 tests and 1 assignment. Okay, is it enough or you want more? 3 enough?
Enough, Prof.
Because you have a project and everything. Okay, I think it's enough lah. It's a very minimum lah. Very minimum. Test 1, 15%. Test 2, 15%, and assignment which involve hardware. Okay. I'm not sure whether I want to make it grouping or individual. So since we have 4 students, I will create 4 topics, and then it can be individual assignment, but you can discuss each other. Okay, you can discuss each other in order to design the project, to analyze, and then I'm targeting to get a journal paper from Scopus Index from 4 of you using the assignments. Okay, so you can submit to the Scopus journals, publish, and then you can use that paper as references for PhD, another level of research. Agree? Agree? Okay, and then the final exam, 50%. Which is July 2022. So this is the chapter 1, the content of chapter 1. Okay, introduction of SystemId. Okay, some of the subtopics. Okay, and chapter 2 on the town parametric model estimation method. Chapter 3 on the parametric model method. Chapter 4, semester break. Okay. Then we have a parametric models estimations. Then chapter 5 is the case study. Okay, there is a link here. Is a link from the internet for the data provided by the university for homework and assignments of the subjects. I think this one is another university. I just share the link. So learning resources, I prefer this book, Arun K. Tangirala, okay, which is Principle of SystemId, Theory and Practice. So I have the book with me. Okay, this one. Can you see the book? So I will not follow all. I just take a little bit from there and share with you. Okay, so if I say you read this book chapter, so you have to read lah. Okay, to get some informations from that particular book. And then the second book is, this one is the guru of the SystemId, Professor Leonard Jung. Okay, on the SystemId theory for the user, second edition. This book is quite advanced. Okay, you need a very high understanding of mathematics, very deep understanding of mathematics. And then another guru of the system ID is the Soderstrom and Stoica. Okay, all in the my website. My what do you call that? My website where I put all the books here, so you can read the ebook by your own. Okay, it's free of charge. And this one is other. Okay, so you can use it as the reference. Okay, added reference. Right, so that is my end of preambles. Okay, is there any questions before we start chapter 1? Ada soalan? Any question? Sorry. David, ada soalan?
Tak ada, Prof.
Liajin, any question?
No question, Prof.
Question, okay. So if there is no question, I move to chapter 1. I already share with you. You got it? You got it? Chapter 1?
Yes.
Okay. So chapter 1. Where? Okay. So this is the chapter 1. Okay, introduction to system ID. So basically, modeling, we have two ways. One is using a derivation of first principle. The second one is using a data-driven, using a data to construct a model. And therefore, when we estimate the model, so it will become the yellow one. Okay, estimate. So this one meaning when the variables have a head on the top, okay, of the symbols. So meaning that this one is called estimated. Okay, estimated. Okay, and this estimated model will be compared with the real plan. So this one is the real. Okay, without head is real. Right. So this output, estimate output, and the real output will be compared each other. Okay, to find the best compromise, the best model that represent, okay, the plan. And after that, you can design the controller. So usually this one is adaptive control, okay, self-tuning control, model, reference, adaptive control, and so on. Okay, beside PID controller. And don't forget, in the real plan, we have a D of T. D of T, we call it as a disturbance. Okay, disturbance during the data-driven modeling. So disturbance is uncertainty signals. We don't expect it comes, but it will comes. Okay, where it come from? It can come from your handphone. Okay, your handphone is a microwave device. So this signal have a microwave device that can enter to the real plan. The second one is from the aircon. When you put in stay in the lab, okay, so when the aircon on, it also contribute a disturbance. Then the one is a 3-pin plug. 3-pin plug, okay, at the wall. You know that? I don't know China. China, yeah, how many volt there, Lijin? China? Plug at the wall. Plug at the wall. How many volt? In Malaysia is 240 volt. 50 hertz. In China, their plug at the wall is different. Am I right?
Is 15 hertz. Was 220.
220. In Malaysia is 240 AC, 50 hertz. So it have a sine wave 50 hertz. And this one can enter to the plant as a disturbance. Okay. So system ID involve a lot of applications. from 4 broad fields in engineering, mathematics, and statistics. Okay, so it will communicate with the system and sampling theory, theory of random process because of the uncertainty, signal processing, and estimation theory. Okay, so it will support the SystemId theory. And the 4 fields here is sometimes being used in order to get the best model from the data. And to be more specific, it involves recursive parameter estimation, model selection, self-tuning control, MATLAB and Simulink, statistic, ordinary differential, difference equation, linear algebra, linear modeling, least square estimation, and so on. So element of the course, we have 5 main elements, basically on the intro, and then the non-parametric and parametric modeling, and then a least square and recursive parameter estimation, model selection, and case study. For SystemId, we can do it online and offline. Okay, so online meaning we stay in the lab with our computer, with our unknown plan, with our data logger system. When we capture the data, and then the data captured will be processed online using the algorithm, okay, either in MATLAB or in computer programming, and produce the plan on that particular time. That we call it as online. But it can also perform as offline, where you run the experiment, and then you capture the data, then you save the data in the pen drive or Google Drive, okay, and then you go back to your hostel, to your house, okay, you have your dinner, you take your bath, okay, you play any sports, badminton, and so on. Then after that, about 10 p.m., you open your computer and then process the data that you captured in the morning or in the afternoon in the laboratory. So that one, we call it as offline analysis, okay? And for SystemId, we have 2 types, which is can be done in discrete time and can be done in continuous time. So I hope you understand. For continuous time, we use S, okay, as the Laplace operator, and for discrete system we use Z or Z as the Z operator. Okay, so what is the difference between continuous and discrete time? So continuous system is varying with time. Okay. Okay. So continuous, this is continuous, okay? So you have a output, something like this, okay? And then your input is something like this, okay? So in the time domain, but for Z domain, it's different, okay? So this one, we call it as a bracket Z, or something like this, okay? Okay, so you have a something like this because you are using a sample and hold, okay? In order to get the data in digital form, okay, and then you plot. So both are the same actually. You can do discrete or you can do the continuous time, okay? So if you are using discrete, the important thing is you must know what is the sampling time. So that matters, okay? Sampling time is very critical if you are using discrete time compared to the continuous time. So the definition of SystemId is building mathematical models of dynamic system based on a set of measured stimulus and response data samples. Okay, so it applies in a lot of disciplines: mechanical engineering, biology, physiology, metrology, economics, and model-based control design. So usually we are focusing on this model-based control design. We get the model, then we design the controller, okay, and design the system. But don't forget that it also apply in biology, okay, to predict the ecosystem, physiology, to predict the human cycle, meteorology. This one is very important to predict the rain, the wind, the hot weather, okay, especially flooding. Okay, so if there is a flood, heavy rain, so that is very important. So that data come from the meteorology office, and they will issue a warning system, okay, via media social, so that the people will aware and take note about it. Okay, and then economics usually on the import and export. Okay, so buying and sellings. Okay, so they predict the value of RM compared to US. Okay, so these all taken into the economics discipline. Okay, so for engineer, we are using a model-based control design. Okay, so some biologists and physiologists, okay, using SystemId, for example, to estimate the eye pupil response and heart rate control. Okay, is a biological system. And then meteorologists and economists build mathematical model based on historical data or time series. Why? Because they want to forecast, okay, to predict, to estimate, to forecast. Okay, sometimes the forecast is not true, but it's just a forecast. Okay, forecast is not true because they don't have any input data. The difference is they just have a data, then they focus. Compared to our field where we are using the model-based control design, so we must have input. The cost, we call it as the cost. CAUSE. And then we must have output. So output is the effect. Okay, effect. In model-based design, you must have this. Either we use the square wave, okay, or impulse as a test input signal, or PRDS, which we will learn later. And then also there is a disturbance, of course, okay. So we have to measure the disturbance in terms of the signal to noise ratio. Okay, so you have the signals, I share there. Disturbance. Okay, you cannot avoid disturbance because once you do experimental to collect data, it will come automatically. Either you like it or not, it will come. And the source is come from the previous talk just now, from the handphone, from the aircon, from the 3-pin plug, and so on. It will enter to your system. Okay. Here, disturbance. Is unknown system. Okay, so it will enter here. Okay, and then we have to see the signal to noise ratio. Okay, is a signal versus noise. So noise is here. This is noise. Okay, and this is the signal that we get, the output. So you have a SNR high, SNR low. So if the SNR high is good, okay, because noise small, but if the SNR is low, okay, so not good, okay, because the noise is high, okay, the noise is high, okay, so high SNR is our choice. When we have a high signal to noise ratio, meaning that we can ignore the noise, okay, sikit je lah, very small noise, okay lah, we can ignore it because it didn't affect. But if the noise is very big in amplitude, it will affect the signals. So that the SNR become not good. Okay, so we don't want that kind of measurements in our data. Okay, so SystemId is a step-by-step. Okay, initial step, identify a model plan and then get the model-based control design, and is an iterative process. Iterative process meaning that we have a loop. Okay, it have a loop. Okay, whether the model accepted or not. If accepted, yes, so you get the final model. But if the model is not accepted, is below 90% best fit, so you have to repeat again the process. So it's an iterative until you get the final model. It begins with the acquired raw data from a real world, and then format and process the data as necessary. And then you select the mathematical algorithm to identify the mathematical model. Then use the resulting model to analyze the dynamic characteristic and simulate the time response of the system. And then use the model to design the model-based controller. Okay, some of the books by Lord FUA'AD, he's Iranian, but stay in the US, refers to the problem of determining the input-output relations of a black box or modeling based on the observed experimental data. Is quite the same. Okay, Zadeh said that the unknown system is a black box system. So if you have a black box system, it's black color, you don't know what's inside it. What is the circuit? How many filters? How many amplifiers? How many other capacitance, resistance, inductance inside the black box? So you simply don't know. That's why is a SystemId, we call it as a process of determining the practical testing of the transfer function or some equivalent mathematical descriptions. So usually is the transfer functions, because the transfer function can inform us whether the system have how many poles, how many zeros, stable or not, okay, faster or not, okay. That is represented by the description dynamic characteristic of the system component. Why we need this model? Of course, in the model-based control design, we want to design a controller. So if you want to design a controller, you must get the exact model first. Okay, at least the model is 90% best fit. The output follow the, the estimated model follow the real model, best fit above 90%. Okay, so that when the models are ready, we can predict the system behavior. And then we can design several type of controllers, either PID, adaptive, self-tuning, and so on. So this is what we talked about just now. Okay, it's a task of using input-output data to build a model, which is the abstract of the process. Okay? It reflects the content of the black box. Okay, so we have the input, which is the probe signal. We have the output, which is the observed response, and this will go to the data acquisition system or data logger system, and from there we use the calculations, okay, to estimate the coefficients, and finally we get the mathematical model. So some books define SystemId as the methodology of building mathematical models based on input and output signals. So it have several steps required, which is the measurement. So you must have a sensor. You must have a data acquisition system or data logger system to capture the input and output data. If there is no data, there is no SystemId. There is no data-driven modeling. After you get that, so you must choose the suitable model structure, okay, for the system. Okay, so is it the model is linear? Is it on the non-linear? What is the order of the system? Is it first order, second order, third order, or higher order? So you must choose the suitable model structure that can fit the unknown model. And after you fix the model structure, so you can apply the estimation method. There are many estimation methods. If you Google in the Google search in the Google Drive, so in the Google platform, you can see a lot of estimation method listed in the many journals to estimate the value of the adjustable parameters. And then you evaluate. Evaluate means you validate the model. Is it accepted or not? Is it give an error, small error? A big error is not acceptable. So the error must be as small as possible. Okay. So some of the definitions of SI, the objective of SI is to obtain a parsimonious model that adequately representing the system. What is parsimonious? Maybe is a word that new to you. Parsimonious model is a model with a few parameters, not many, a few parameters as possible for a given quality of a model that represent the model quality. So this is the best, few parameters, not complicated, okay? Because if you see that in the transfer function form, if you plot the poles and zero on the S-plane or on the Z-plane, you can see that some of the poles and zero are near together. So when it near together, it can cancel each other, okay? For example, you have a fifth order system, okay? Okay, can you see? Right. So this is your S-plane. So you have a over here, okay, and then you have a over here, and then you have zeros, which is over here, and then over here. So you can see that the poles is 3, is a third order, okay, because 3 poles. But you can see that this one, if the value is -2, the poles is -2, and the zeros is -2, and it is what do you call that? Overlap each other, overlap each other. So meaning that it can be cancelled out. Poles -2 and zeros -2 can be cancelled out. Cancel each other. So meaning that third order is not relevant anymore. Now it become second order. Okay, because this one, the effect of the poles has been cancelled out by the zeros. Okay, so this is what the parsimonious model, okay, talk about. Okay, where we have a few parameters as possible for a given quality of the model. Okay, so I stop here. Okay, it's already 11:47. So I leave it to you to read. Okay, from the given slides. Okay, then I will continue again on Tuesday next week 2 p.m. Okay, so next week is Ramadan. Is fasting month, bulan puasa. Nevin, puasa tak? Nevin, pernah puasa? Pernah puasa?
Tak pernah, Prof.
Cubalah. Cubalah. You can feel that your body feel very light. Your stomach will rest for 1 month. 1 month. Rehat pada siang, tapi malam boleh makan lah after sunset. It's good for the health actually. Okay, so still the class still on, but maybe I quite slow sikit lah. I hope you understand because next week is the fasting month for 1 month in April. Okay, Kong, Lizin, Junyi.
Yes. Okay, Prof.
Class today is finished and we continue next week. Okay.
Okay.
Thank you
Okay.
for
Okay,
listening. I will share the YouTube channel link later after I process the MP4. Thank you very much. Thank you for your listening. All right. See you next week. Bye-bye.
Bye-bye.
Thank you, Prof. Goodbye.